In this video, we're going to answer a particular type of derivative question. So this is a question that asks you to determine the equation of the tangent or tangents to the curve y equals x squared that passed through the point 0, -2. So initially this question might not look that different than ones you've seen many times and ones that are not too difficult, right? But when you draw a picture, you'll see how it's actually quite a bit different. So this is a curve y equals x squared, and then where is the point 0, -2? It's down here. Well, that's a little different, right? Normally, we're given a point that's on the curve, so we can just find the derivative and then sub that point into the derivative, and that will give us the slope. But this point is not on the curve. So what do they mean, the equation of the tangent to this curve, if it passes through this but it's not on it? Well, if you look, there's actually two tangents that will sort of pass through this point, right? It just touches the curve, and there's one sort of symmetrically on the opposite side. So that's supposed to touch the curve. So these two tangents will go through this point. So, well, what are we going to do? Well, first, probably instinct would be to take the derivative, and that would be a good instinct. So we know dy by dx is equal to 2x. Now normally, if the point was on the curve, we could just sub this point in, x equals 0, we just sub that into this. But if we were to do that, what would that give us? That would give us 0. It would give us the slope of the tangent at x equals 0. But I don't care about the slope of the tangent at x equals 0. Clearly that's not the one I'm looking for. So what are we going to do? Well, we need to sub in this point, but I don't know what that point is. So let's just give it a letter. Let's call it a. X is equal to a. Well, if x is equal to a, then y would be equal to, since it's on this curve, would be equal to a squared. So let's evaluate the derivative at x equals a. So that'd be 2a. Okay, now what? It doesn't seem to help too much, right? We know the slope is equal to 2a, but that's not a real number. That's not a number, right? I need a number. So do we have another way to get the slope? Well, yeah, I also know the slope is equal to y2 minus y1 over x2 minus x1. And that'd be good if I knew 2 points. Do I know 2 points on this line? Well, I know this point, and I also know this point down here. Right? That was 0, -2. So let's use these 2 points. So y2, I'll take that to be minus 2 minus a squared all over 0 minus a, and then that's equal to m. But m is this, right? So m is 2a. So 2a equals minus 2 minus a squared over minus a. And if I multiply both sides of this equation by minus a, I'll have minus 2a squared minus 2 minus a squared. I'll add 2 to both sides, get rid of that one, and then I'll add 2a squared. So we got 2 equals a squared. So a would be equal to, I'll take the square root, so plus or minus root 2. I'm going to leave it like that. So that's this point a. And why did I get 2 answers? Well, remember there's 2 points. So this point must have been root 2, and this point must have been minus root 2. So therefore the points of tangency are, so the one was root 2, and what would y have been? Well, it was root 2 squared, which is just 2, and the other one would have been negative root 2, and then negative root 2 squared is also 2. So those are the 2 points. What are the slopes? Well, remember the slope was equal to 2a, So this one would have been 2 root 2, and this one would have been, call that 2, would have been negative 2 root 2. So now we just have to find the equation of the line. So y equals mx plus b. So y was 2 root 2 times root 2 plus b. If my power dies, I'm not doing this example again, so you'll have to figure it out on your own. I'm going to skip some steps. So y equals 2 root 2 x minus 2, and then the same thing over here. Russian because, as you saw, my power is on its last legs. It would be 2 times b plus. So this would just be, is that 2? That would be 4. Right. So b would be equal to negative 2. Well, obviously b is equal. Should look at the question. Obviously b was equal to negative 2. Probably watching me do that thinking, what is he doing?